welcome to your weekly dose of mayhem, the hottest show around. So hot, in fact, we set off the fire alarm. Let's talk about open house. Explain the open house, Ahmed. Big guy.
Well,
Big man.
I don't know
Ahmed,
if I'm the
big
correct
guy.
person to.
Big guy. Big Ahmed. Big guy. Oh yeah, you want the. Explain the open house, Ahmed.
So, as you were saying, I wasn't there, but from what I understand, it's basically a way for us to, or the entire school actually, to show, um, what's happening at the school. What are the different things we offer to new people who are interested, right? Pretty standard stuff. And so, as a part of that, a lot of them come down to the lab, and so we, show them around, show them the robots, and honestly, how do you think that went?
It went pretty well until the incident, which we'll bring up, which we'll talk about. To
You make it sound worse than it is.
Yeah. Um, so we had a bunch of tours. They from families who were touring all of Nichols. They came down to the lab just on their tour. We were showing off some of our robots. We were building robots, so they got a live view of what it's like to actually work down here. And then it happened.
Yeah.
So for those of you who don't know, we have two fire doors in our lab on the side of the room with all the tours. So if there's a problem, you can get out. If you open up that fire door, it sets off the fire alarm and calls the fire department. So, not everyone knows that. And those fire doors obviously lead out to the hallways on either side of the lab. And those doors on either side of the hallway look fairly normal.
Yeah.
They look
from the inside.
It looks like
they say
yeah.
emergency exit. This will sound the alarm if you push it. It says that on a giant label. You can't miss it.
You can't miss it.
On the outside, it looks like a regular door.
It looks like a door that you should be using to get into the lab. So someone tried to open it from the outside,
Which for some reason also called the fire department and set off the alarm.
So it was weird. Someone tried to open it. It started beeping, and it would beep like every minute for like 15 minutes. And then maybe someone tried to open it again, and then it started alarming. The fire department wasn't called, and it didn't set off the fire alarm, but the door itself started beeping. And
I feel, what I feel like it might have happened is that they opened it from the outside. It started beeping, and someone was like, "What's all this racket? Why is it beeping?" And they pushed it from the inside, and then it set off.
I don't know I don't think anyone pushed it from the inside. That could have been possible. I don't know. Regardless, it's sorted out now. Everyone's okay.
Yeah.
And I don't know. I left before it was resolved, so I don't know how they fixed it. Anyway.
So about open house, other than that, so I know you were there. So what did we show to people?
So we had some of our robots running. The two drivetrains that we've built this year for FTC, we had those running. One of them, we were letting the can we talk about white teams? Can we talk about the drivetrains? We're going to talk about the drivetrains we picked. So we had white team's drivetrain moving around the Mario Kart drivetrain. That one was driving. People were allowed to drive it. It's an X drive. It's a circle. So it's really cool to show off people. Oh yeah, robots don't have to look like cars. They can be circles, which is something people get really excited about. And then there was the Green Team Mecanum drivetrain, which does something really cool, which we can't talk about because we're gonna do a full video on it in a while. So we're not gonna spoil that because we're gonna let the programmers talk about that.
Yeah.
And we also had a bunch of kids working on that side of the lab, working on the ruckus spots. People could just walk by, and we were working on it, and they could come up and ask questions like, "What were we doing? How does it work?" Which is pretty cool.
Yeah.
So they got to see in action what the lab looks like when there's a full team working on a project.
Yeah. So how did you think that went? From just showing people everything that we do down here.
It went well. The admissions office at Nichols says it went very well, and apparently they got some sign-ups, I guess. I don't really know how it works.
Yeah.
It worked. Everyone, because the open houses are interesting because the students who don't do robotics at Nichols are the ones who give the tours. So it's a cool opportunity for them to come down to the lab and see how we operate down here.
We did kind of take it over from them though once they led people down here a little bit.
Yes, they would lead it down and we would give the presentation, but they got to see the presentation, so they got to learn some stuff.
Yeah.
So not only did new families get to learn some stuff, but so did students of the school,
Yeah.
which is
And
always fun.
that's quite interesting that that did happen.
Yes.
So I know that like it went pretty well, but if you were to change like a couple things, how do you think you could have made it like more engaging?
I think we should have set up Mario Kart, but we did not have the room because the normal place that we set it up was taken by teachers who were giving just like teachers who could meet with the students. Because normally we set it up upstairs in the reading room, but that room was being used by the wellness department and student counseling and college counseling. So we weren't gonna take that away from them. But if in an ideal world we would have had Mario Kart set up and we would have let some people drive, because that would have been really cool. But
So yeah, I think maybe for something else we'll definitely be working on RoboKart in like tangent with like outreach programs.
Yeah. RoboKart is only gonna get better in the coming months. So
Yeah.
once the off season really gets going, the RoboKart
We've already got a lot of stuff planned for that, including like videos and like different tech we can put together to like do like lap systems. I think we talked about that in episode 2. But yeah, that's very exciting. So let's
FTC progress.
FTC progress.
FTC
yes.
progress.
Yeah.
FTC progress.
It's one of the words in the name of the video.
Yes.
So
We'll talk about white team and then we'll talk about green team.
okay. So
Talk.
speak. I will. So you're putting me on point here.
What is white team doing? What can you talk about that isn't classified?
Well, I don't actually know what is classified. I'm sure that a lot is, and a lot of the stuff that
Someone at
is.
the door. Someone might be at the door. Wood.
Someone might be at the door. Okay,
Anyway.
you go get that.
Alright, I'm just gonna
I'll
talk about white team. I'm gonna see who's at the door.
Yes. Okay, so, I mean, I'm not entirely like sure about everything that's happening with white team because I'm actually more focusing on the programming, and the programming is both green team and white team. We're trying out something new where we just have a set of dedicated programmers that just do both of them, and so. But on the like mechanical and CAD side, things have been going pretty well. We are working on like our sort of arm and depositing system, and the CAD's coming along as well. We've got some cool hand designs and some concepts, and the drivetrain is quite similar to some other robots that we've made. So, but we are going to work on that, and make it a little bit more custom for the use case that we have. So, what about green team?
Green team. So, do you want to pull up the CAD?
Yeah, hold on.
So green team has been making some very good progress on the CAD side of things. So this is going to be the first reveal of the green team CAD and a whole robot before the reveal video. So once the reveal video comes out, we'll have a lot more in-depth specifics of the robot, and we'll go into a lot of the cool stuff that you can't really get out of the CAD, a lot of the programming of it, which is going to be super cool this year. But the CAD is pretty much done. We just need to add some electrical components to it, and cameras and such. But besides that, the CAD is at a point to where we can show it off right now.
Yeah.
Yeah.
And I'm going to attempt to bring it up.
Okay. Yeah. Final assembly was gonna be the assembly you want.
Final assembly, got it. Okay.
Yeah. So so for those of you who were at Robot in 30 Hours. This robot will look very familiar. We learned a lot from Robot in 30 Hours. We committed to the Mecanum drivetrain. We are committing to a ARM type system, and we have a very interesting intake. This is our first year in FTC. We're really doing an internal handoff inside the bot, but we think we can get it in a working order. So we are using a lot of stuff that we learned from FRC last year to we're using a lot of the concepts that we learned from FLC and FTC last year in this year's bot. Do you have it pulled up on the stream?
I've just about got it.
Yeah, the CAD isn't completely done. There's hand stuff that still needs to get done.
Oh, this is quite interesting, actually. Let me see if I can just transition. There we go. All right. So this is final assembly, right?
Final assembly.
Yes. So
You're
this
under
is
it,
actually
yes.
I haven't actually looked at this that well. I haven't been keeping up with this, but this looks pretty cool.
Yeah. So, I think I'm gonna move the robot around on my screen, and I think it will translate to your screen.
I don't think like moving the actual components.
Mhm.
Oh, that might, yeah.
Yeah, it does.
Okay.
So, if you zoom in on the intake, which I just moved down, this intake design was designed by a kid named Finn. He spent a lot of time on that. He did a lot of prototyping.
Oh, I just
Um,
zoomed in on the wrong thing. Whoops.
He spent a lot of time prototyping on this intake. Basically, how it works is when there's two pixels next to each other on the ground, presumably coming from the human player station, you just ram up into the wall, and the intake comes up, and then the pixels are locked in right at that one spot, so they are always will be in the exact same spot inside the robot. If you look at those linear actuators, these are something we haven't talked a lot about. We went to an outreach event a couple weeks ago in Odin, and there was this company called Studica Robotics there. They've been around for a while. They've made stuff for more classroom robotics, but they recently got into FTC, and they basically make it's a servo with a rack and pinion system inside of it,
I think it's a worm gear.
or maybe it's a worm gear, something like that. And it's a servo, so you control it with a servo and a servo wire. But basically, how it operates is like it operates how like a pneumatics would in FRC.
Yeah, could you just do that?
Yeah. So it looks like a pneumatic cylinder, but it's actually a servo. And since it's a servo, you can actually do go to position. So with a pneumatic cylinder, you have an in and an out position, and that's all you can get. But
Yeah.
since it's a servo, you can do like a halfway in or a quarter of the way out. Like
Yeah, and that'll be really useful. And we did test some of that. And so, one thing I'm seeing here is that you do have it like you've got this on an axle. So these are actually just responsible for the sort of rotational movement of
Yep.
the thing.
yes, the intake is on a half-inch hex axle, and the actuators, the called Studica linear actuators, um, are just responsible for bringing it up and down.
And so,
Um,
yeah, we've got some more of those actually on the arm here.
Yes. Also, if you are interested in Studica linear actuators, I highly recommend them. They've treated us pretty well so far. They come in two lengths, 50 millimeter and 140 millimeter, and they have a high speed version and a high torque version, and there is a there's a Foley working version of them in the EMCAD library, which I made.
Nice.
So if you thinking about them, open up that file, EMCAD Studica linear actuators, and play around with them for yourself.
Right. And
yes.
so, is there anything else you want to highlight about? I do see that you have the control and expansion hub. Actually, they're two control hubs, but yeah.
So yes, since for the robot this year, we are doing a control hub and expansion hub. Traditionally, we've done one control hub with Spark Minis to turn those motors into turn those motor into servos, so you can plug them into the servo port. But this year, with a lot of the programming that we're doing with this robot, a lot of the very intense programming, we needed the two control hubs, one control hub, one expansion hub, because we needed those encoder ports. We are using all 8 encoder ports this year, which is something we haven't done in a while. Yeah, so we have those two on the side, on the wings of on the shoulder parts of the robot, and we have the battery will go in between them, but that is not yet catted. And if I'll bring your attention to the arm, again you see two Studica actuators on the arm, so you can get that nice extension. That extension is for primarily the climb, which you can see with those two little hooks. And then on the end we have this core hex motor, which works as the wrist, and then we have a servo into a servo horn connected to that 3D printed piece coming off the core hex motor, which acts as this motion. So it's just another angle of the wrist.
Is that this one right here? The one on top of it? Or is that something else?
So no, those two weird blue floating servos are the hand, which isn't done yet, because we're still prototyping the hand. We've kind of settled on a design but we don't know exactly how we want to implement it yet. We're still trying to integrate it into the rest of the robot pretty well.
Yeah. Okay.
But the yeah, I can't really speak on that because I was not really a part of that group making that.
Yeah. So I think we should probably keep some pace with time. But one thing I just want to highlight real quickly is the odometry wheels, or the dead wheels near the on the bottom of the robot here. So you can see that there is two on the side and then one like this. And so those in tandem with the new Vision Portal April tag stuff will give us really good field localization for both auto and like automated teleop subroutines. And that's something that we at the programming sort of unofficial programming team are working on at this moment. And so that's exciting.
Last year, the white team did a field-oriented bot, and this year both teams, I believe, are doing field-oriented.
Yeah.
We've decided that we'd like that more than normal robot-oriented driving, but also FRC did field-oriented, obviously, with the with Swerve. But so yeah, all the teams this year have committed to the field-oriented driving, which is something we're very excited about. Me personally, I'm very excited about that because I prefer field-oriented. Okay, let's make sure that we don't run out of time here.
Yeah. So let's talk more about the. Do you want to talk about the BNMA dinner?
BNMA dinner. BNMA stands for Buffalo Niagara Manufacturing Alliance dinner. So I'll keep this short. Last night, a couple of us from the FTC teams went to this dinner. There was a lot of expos of local manufacturing companies and the stuff they've been doing. A lot of really cool 6-axis arms and kind of like hive mind brain logistical robots that move in tandem on like tracks and stuff, maglev kind of thing.
Yeah, I probably should have come to that. I thought it was just gonna be eaten.
No, we did eat. Yeah, it was super fun. We showed off again just some of our FTC bots. Good outreach competition. Not really a good outreach for us. Not really geared towards kids, more towards adults. But there was some very impressed professional engineers with some of the stuff we've been working on, which is always fun.
Yeah.
That's all I've got to say on that.
Yeah. So that's a good sign that we are doing well on our technologies and whatnot. So one thing I want to talk about very quickly is this thing that we did this week, which is, so we use a lot of polycarb in our robots, and because it's pretty cool, it allows you to get custom parts, and so what we used for that is we just used like regular 1/4-inch sheets on our CNC machine, and then we like cammed the tool paths using Autodesk Inventor. But the problem with that is that Autodesk Inventor costs a lot of money.
Yes, quite a bit. And our subscription was up, and we were like, we don't want to pay for this anymore. There's got to be a free solution.
And
lo and behold, there is.
It turns out I was working on it 2 days before that issue arose, which is hilarious timing.
Yeah.
So this solution that we found is an open source, free to use multi-platform CAD software called FreeCAD, and it is like primarily designed to be a CAD software, but either I'm not good at it or it's just a little bit weird because it's quite finicky. But the path workspace in it is like the CAM workspace, basically.
Computer-aided machining, which is different from CAD because that's what's like the G code for machines to follow.
Yeah, so it's basically the tool path programming. It tells the machine where to go. And that was actually quite good. It was pretty full-featured. It had all it had drilling, it had cutting out like the pockets and the profiles, it had all sorts of stuff. And there's a lot more that I just haven't looked into yet. About like keeping the print, like keeping the like the cutout like profile in place using tabs, where it just like slightly misses a little bit of it to keep it connected so it doesn't go flying off. So that's some stuff like that. That's pretty cool. And the thing is, we were looking into a lot of different solutions. Like we were looking into Onshape, and we were looking into this other one that like works with Onshape, and it's cloud-based called Kirimoto. But we found that FreeCAD was actually the most fully featured, and it was, free open source multi-platform, so anyone could just download it and use it, and it does support our like CNC software. So that's pretty cool, and we saved a lot of money. And so if there's anybody else out there who wants to save a lot of money and doesn't want to use Autodesk Inventor, check out FreeCAD, and check out, if you want to use cloud-based, check out Kirimoto, which is slightly less fully featured, but still pretty good.
We didn't. I was in charge of finding out how Kirimoto worked, and I looked over at what Hamid was doing with FreeCAD, and I was like, we're doing FreeCAD, because it was clearly more what we were looking for. Yeah, so since we have now a much simpler and free version of Autodesk Inventor camming with this FreeCAD thing, we have routed recently, a couple days ago, the first completely student cammed and routed piece was ever produced by.
And technically, student CADed.
It's technically student CADed, but
it was a square.
It was a square. Because in the past, with Autodesk Inventor, it was very unintuitive, and it would do things with the router that made the router significantly more dangerous to run. So
yeah, remember at one time, I was working in the lab, and Mr. Hiller had just walked away for a second, and I was looking over at the CNC, and it wasn't moving. The bit was spinning, but it was just in the air, and it wasn't moving.
Yeah.
There was just an error message on the screen. So I was like, Mr. Hiller, what is that? And he went over it, and he's like, oh, there's something wrong with the G code. He like redid it, and he like refollowed the same toolpaths. It got to the same point, and it got a little further, and it did the same error again. And then he tried it again, and it got a little further, and then did the same error, and then finally, like the fourth time or something,
it got
all the way.
So in the past, the routing has been handled mostly by the mentors, but now with this FreeCAD thing, the routing can be done mostly by the students, which is really cool.
Yeah. There was also this annoying thing with Inventor, where after it was done, like doing a part, it would go to
the origin.
It would go to like the place where it had started. So like if this is the origin, you imagine it goes this way, this way, this way, this way, and then what it did is it went like down to like z equals 0, which is the surface of the stock, and then it just scraped its way across to a different location. Which really
would scrape up the polycarbon and make it a hole.
Yeah. So we had to like physically go in and delete those lines of G code, but with FreeCAD, just a quality of life feature, it just goes up to Z5 and stops.
Yeah,
which is way better.
The next topic is FOL. Since we are running low on time, I think we're gonna skip over this and probably just mention what events we're hosting for FOL.
Yeah.
So last year we've been hosting an FOL qualifier at our school for a while now. Last year we hosted the first FOL states. This year we're doing those again, and I think these dates have been released publicly. The FOL Buffalo qualifier is December 16th, and the FOL New York State Championship is FOL Championship, also held here, is on the 10th of February. So yeah, those are two events that we run every year. Good for our 3 FOL teams. They always have a lot of fun there. It's a lot of teams come down to our school to go compete at those events. And alongside that, I'll just mention this briefly, we're also hosting the FTC event this year.
Which we did talk about.
Which we did talk about in the past
time.
Okay.
And I think that's going to be it.
Yep.
We did kind of overrun quite a bit. But
yes, we did go way... Yeah, this was supposed to be 15 minutes, and we talked for half an hour.
Yeah, we just got so much stuff going on,
I mean, that's probably good, because the podcast is getting interesting now, because the robots are getting interesting now.
Yeah. Last time it was like maybe 10 minutes. This time, we got a lot of stuff going on. We're just keeping that up. But I think without further ado, if you've got nothing else to say,
I'm good.
Well, that's it.
See you next week.
We'll see you next week
for your weekly dose of mayhem. Good night, everybody.